Hi everyone. The problem now that we are going to solve involves the input table as user queue. This table has below columns user ID, which is the ID of the user, username, which is the name of the user, weight, that is the weight of the user, queue position. This is the order in which the user can enter the elevator. So this is a elevator problem. So whoever has the queue position as 1 will have the highest privilege to enter the elevator, followed by the one with queue position as 2 and so on. So this way the people can enter the elevator in this queue line. Now the elevator has maximum capacity of 400 kg. So it can accommodate people only till the overall weight is within 400 kg or equal to 400 kg, not beyond that. So these people will keep entering, and ultimately the elevator cannot accommodate any more people if the overall weight goes beyond 400 kg. So we have to find out who will be the last person who will be entering the elevator as long as the overall weight is within 400 kg. Now, to understand this problem further, there is a small demo that is here. So we have taken the same input here. We have all the details, and this is our elevator in which people will start entering in the queue position order. So now what we will do is, as we know, the maximum capacity of the elevator is 400 kg. So we will just what we will do is we will allow people to enter one by one. So let's allow Ramesh to enter. So once Ramesh enters the elevator, the overall weight inside the elevator is 105, as that is the weight of Ramesh. Now let's allow Suresh also to enter. So if Suresh enters, the overall weight is 155, which is still less than or equal to 400 kg. So elevator can still support these two people. Now let's accommodate Mahesh as well. Let's allow him to enter the elevator. The overall weight is 285, which is the sum of weights of Ramesh, Suresh, and Mahesh. Now let's allow Ganesh as well. So the overall weight is 325. Still, elevator can support this. Now let's allow Rajiv also to go in. Oh, now the elevator capacity has been breached. It has gone beyond 400 kg. That is, overall weight is 405, something which the elevator cannot accommodate. So Rajiv cannot enter the elevator as it is full. So the maximum weight now it can support is 325 with these people in this order. Okay. So we have to give the highest priority in this order. So now that people have entered and the next person cannot be allowed, we have only these people entering the elevator. And who is the last person? It is Ganesh. So that will be our output. We have to show the person who can enter the elevator at the end as long as the overall capacity is within the reach. That is, in this case, it is 400 kg. So we will work on this problem and try to get the solution. Okay. So now let's talk about the approach that we can take here. So for this input, what we will do is at every point, we will find the overall total. Let's call the column as overall total. Okay. So now what we will do is this will represent at a given point of time what is the overall weight inside the elevator. So if only Ramesh enters the elevator, the overall weight of the elevator will be only the weight of Ramesh. Now if Ramesh and Suresh, if both are inside the elevator, it will be sum of these two, right? So it will be sum of weights of Ramesh and Suresh. So it which will be 155. So likewise, we have to keep adding as and when we allow people to enter. So this way, we will keep finding the total as per the queue position in the order of the queue position and keep adding as and when the people are allowed to enter the queue in the elevator. So this we will compute and we will do for almost everyone till the last person. And once that is done, once that is done, we will find out till what point the elevator is able to support. So at this till this point it is able to support. So then what we will do is we will find the max of this column. Okay, the max value of the column where it is supporting. So let's call this as elevator supporting or elevator can accommodate. Let's call this column as this, and it can accommodate this, and this. Not this. No longer this cannot be accommodated as the overall weight is gone beyond 400 kg. So it can support this. Okay. So the first step, what we will do is we will find this totals across each of the entry by summing up the previous entries. This is kind of a running total. Then we will check till what point the elevator can accommodate by checking the maximum capacity of the elevator. So it can support this and cannot support beyond this. Among the entries that are supported, we will find the max. Okay. And then wherever the max is find whatever we have found out, we will just fetch that entry. And this way, we will solve the problem. Okay. So having understood the approach, let's work on and write the SQL query for this. Okay. So we will operate on the input table, that is user queue. So like we said, as a first step, we will keep all the columns as it is and we will find a running total of weights. Okay. So how we will do that? We will use the sum function on the weight column and we will give the window. How the window we will given? It will be in the order of this queue position. So we will mention order by queue position. So this will be our running weight, we can say. Okay. So let's run this and see the output. So we have got the output like we discussed in the approach. For every person, as and when the person is included in the elevator, the respective overall weight for those individuals, it is present here now. Okay, so if only Ramesh goes inside, the overall weight is 105. With Ramesh and Suresh, the overall weight is 155. With Mahesh included, it is 285 and so on. So we have identified this, that what is the running weights that will come in as and when people enter the elevator. So what we will do is we will move this inside a CTE. Let's create a CTE. Let's call it as elevator CTE. So this is our CTE that is created, and on this CTE, that is this output that we have created, we will operate. Okay, so this is elevator. Okay, let's call it as elevator CTE. So we will operate on this data, and now what we will do is we will keep all the columns. Okay, and we will check. Now as we discussed in the approach, now we will check if which are the entries till where the elevator can accommodate or it cannot accommodate. So that decision now we will be making using the case condition. So what we will do is we will check if this running weight that we have just identified, is it less than equal to 400. That is the overall weight of the elevator. So we can define this as a variable as well. For now I'm just hard coding this value. Okay. So if it is less than equal to, then in that case, we can say that this entry is allowed. So we can say yes, that this person can be accommodated. Else, it will be no. This will be can, let's call this column as can accommodate. Okay, so we have done the solution till here. Let's run this and see the output. Okay, so there is some, okay, as is missed. Let's run this now. Okay, so now we have now the solution that we have written, with that we have identified what is the running weight. Okay, what is the running weight, and then we are making the decision whether those entries can be accommodated in the elevator or not. So these two columns is what we have added. And as we discussed, with 400 kg as the maximum capacity of the elevator, we can accommodate only till Ganesh, because the next weight, if we add of Rajiv, it will go beyond 400 kg. So now we will operate on this data only. So what we will do is, let's move this data as a part of a CTE. Okay, and let's call it as weight CTE. Okay. So this will be our second CTE that we have created, so that we can create as many CTE as we need. With the first CTE, we have to add the with clause, and going forward, we don't need to add the with clause. We can just specify the CTE name going forward. Okay. So now we will operate on this second CTE, that is weight CTE. So what we need to do is, we need to only focus on these rows. Okay, the rows which can, in which the user can be accommodated in the elevator. So what we will say is, can accommodate, we will filter those entries, can accommodate as Y. Okay, so let's see this data first and then we will proceed ahead. So now we have reduced the data that we were working on. So these are the people who can enter the elevator. So this is our interest area, like this is the records that we are interested in. But now our interest is only finding the last person, not all, just the last person. So how do we do that? What we will do is, we will find the max of the running weight. Okay, we could also do like finding the max of the queue position, that also is fine. So any of this we can use. Okay, so among this record, we will find the, say, max of the running weight. Let's find max of queue position itself. So find max of queue position, and this, let's name it as required queue position. So this will give us the queue position which is the last person who entered. So among this, 4 is the maximum. So it will give the value as 4. So let's run this and see the output. So we got 4. Now what we will do is, uh, we will operate on the input data, okay, and just get this record. How we will get? So what we will do is, we will write a select statement operating on the input data. What is the input table that we had? So the input table that we had was user queue. So now we will just filter on this user queue, okay, and we will write a filter condition using where clause, and we will say that queue position is equal to this, we will take as part of the inner query. Okay. So what we have done, we have first identified who is the last person, okay, using the queue position, and now we are just fetching from this input data the record of that queue position. So let's run and see the output. So we have got the output. We have got Ganesh as the output, as he will be the last person entering the queue in the elevator whose maximum capacity is 400 kg. So now let's summarize how we have solved this problem. So as we discussed in the approach, what we have done is, first of all, we have found the running weight. So this will give the overall weight as and when we allow each person in the queue order to enter the, in the queue position to enter the elevator. Okay. So once we have that, we will check whether an entry is accommodated in the elevator or not by comparing it with the max capacity of the elevator, that is 400. If it is accommodated, we will give the value y, otherwise we will give value as n. Now what we will do is, we will find the max value among those who can be accommodated. We will find the max queue position, and then for this queue position, we will just fetch the data from the input for this queue position. So this way we have solved the problem. Okay, and this is the query that we have written. So please go through it. I will be adding the create table and insert statement in the description. If you have any alternate solution, please post in the comments. Also, if you found this video useful, please like the video, please share it with your friends. If you have not yet subscribed the channel, please subscribe and please provide your feedback in the comments. Thank you.